Design Guide. Combined analysis design is performed in the design toolbar by running design steel to design all steel beams and columns, design concrete, design all concrete beams, columns, walls, design all the design steel beams, columns, concrete beams, columns, walls. By selecting gravity static of the RSA, control the class of the combination, consider that the slabs require a certain amount of the user interaction, therefore design separated by running design slab to design all slab panel areas that lie outside patches, design all slab panel areas that lie inside of the patch, design punching shear. Design all punching check items not available in the Australia head code. Floor vibration can be checked by running check floor vibration tablets responsible for floor dynamic oscillation. Design toolbar contains the following commands. Option, open the design option dialog box, validate model with any of the design issue that might exist. Design steel gravity initiates the analysis design process for the steel members of gravity combinations only. Design steel static initiate the complete static analysis design process steel members in the structure. Design steel RSA initiate the complete RSA analyst design process for the steel members in the structure. Design concrete gravity initiates analyzing design process for all concrete members and structural gravity combinations only. Design concrete static initiates complete static analysis design process for the all concrete members instruction. Design concrete RSA initiate the complete RSA analysis design process for the concrete members in the structure. Design design all gravity, initiate the analysis design process for all of the member structure gravity combinations only. Design all static incomplete static analysis design process for the all members of the structure. Design RSA, initiates complete RSA analysis design process for all members in the structure. Patch column, creates a column patch which is adapted with the specified created column patch property set. Patch beam creates a beam patch which is adapted with specified create beam patch property set. Patch wall creates a wall patch which adapts with specified with the create wall patch property set. Patch panel creates a panel which adapts to specify the created panel patch property set. Design patches, design check slab reinforcement all slab areas inside patches. Design slab, design check slab reinforcement in all slab areas not inside patches. Add check, use add punching shear check around all common wall perimeter. Design punching shear, performs punching shear checks. Proceed performing punching shear checks. Add check, use add floor vibration check for slab area. Add check floor vibration, performs floor vibration check. See how do I check vibration for all vibration check items related. Commands, ribbon tools, design option, how to apply manage design option, modify the design option, current mode, click design option, review, edit settings as required. If you change any settings, click OK to apply with the change of directly the current project, save the change of the settings back to active settings to activate active defaults for future projects, or cancel the changes. You can also click load to revert the design option, specify the activate settings sets, modify the design option, default future project, click home settings, design option, page the dialog, select with the settings to be updated, then review, edit settings as required. You can update any settings by simply selecting in the drop list and does not need to be active. If you choose change any setting, click OK to save the changes and select in setting sets to active as default future projects which are set as active. Cancel to change. The cancel changes. Design option generally use multi-core process for the design level. Leave the option selected to take advantage of multi-core process during design phase. Run chase downs concurrently. Leave the option selected to take advantage of multi-core process during chase down analysis phase. The above options only display the design settings or accessed for the setting dialogs. Home toolbar, gravity design, fixed column nodes horizontally. When selected, the option automatically applies lateral transitional fixed floor reports to the column nodes of 3D analysis performed during gravity design process. This is useful for the early design stage lateral system have not been established. The automatic lateral supports can be removed unwanted lateral displacement that may prevent the analysis completing and producing unrealistic forces. Fixed column node horizontally setting does not apply with the column node with the rigid floor diaphragm. Analysts run separate prop for the analyst all static and 3D analysis performed during design static. Design option analysis, analyzing option page will allow you to choose whether the first or second order 3D analysis performs steel structure particular should consider the running of first order analysis for the initial gravity design before switching second order analysis final design. Solve lateral load cases. Isolation nonlinear analysis required during design. Nonlinear analysis lateral load cases will often solve all take a long time to converge and conserve the isolation, especially true with the compression only with the foundation mounts. Hence, it suggests the check box is cleared. If you need to see the result of the individual lateral load cases, it can either run over the analyst directly with the analyst ribbon. If you know that the analyst does not fail, you can select the check box stability coefficient tolerance. There's a very deflection where you want to use the calculation stability coefficients of the potential with the high stability coefficients could erroneously be reported to prevent stability coefficient tolerances provided the means for the control of the value deflection that can be safely ignored. Setting with analysis first order, the second of the order drift, the less of the tolerance defined default stack height of 1/10,000 stability coefficient return the non-applicable to note the say with the drift small enough to be ignored. Reduced stiffness factor is exposed one for the analysis and set with the second order of the correct design AISC specification with the DAM. This should be set at 0.8. All terms of setting of analysis first order explode. The reason for that any of the second order analysis if possible the alter this fact that this is a set value says if you set the value to say 10, this would stiffen both the modulus of elasticity, shear modulus elasticity G, and by a factor of 10 second order analysis, although the result will not be able to use for any valid design, should not be possible to run analysis, see whether the matter might fail. Design hence cause of the analysis instability factor can be reduced towards 0.8. Further investigation, design options, concrete reinforcement parameters, reinforcement anchored length of the parameters are even the calculation ultimate bound structure for which the anchored lengths are determined. Eurocode plain bars bond quality modifier allow range from 10 to 1, default is 0.5, type 1 bars bond qualified modifier 0 with 10 to 1, default 0.8, type 2 bars bond qual modifier allow range 0.1 to 1, default 1, ACI plain bars bond quality modifier allow range 0.1 to 1, default 0.5, deform bars bond qualifier modifier allow range 0.1 to 1, default 1, design option concrete beams. The page have several subpage setting of the option. The use of the beam design concrete beam reinforcement setting. This page uses set limited range specified for the bars used the design general of the country the available bar side of the property taken with the material of the reinforcement database according to the country selected. Longitudinal bars minimum bar size set of the minimum allowable bar size of the use of the design process. Maximum bar size set of the maximum allowable bar size that can use of the design process. Minimum size bar size set of the minimum allowable side bar size that can use of the design process. Minimum top steel clearance spacing. Minimum allowable top steel clearing space that can be used for the design process. Minimum bottom steel clear spacing. Minimum allowable bottom steel clear spacing that can be used for the design process. Maximum tension steel spacing. Maximum allowable tension steel spacing that can be used for the design process. Maximum compression steel spacing. Maximum allowable compression steel spacing that can be used for the design process. Using single bars with a beam width of greater than or less than equal to single bars are only permitted to beams less than width specified steel overall strength ACI only. Factories use seismic design to account with the reinforcement steel yielding over strength short pans maximum length smaller span smaller than the value set here with the treated short spans. Support bars are short spans merged with the span bars. Concrete beam and the detailing option setting of the page relate to the detail produced but have no effect on the design. Longitudinal bars use the same size bar multi-layer arrangements select to use the same bar size of each layer, same number of the bars in each layer, select the use the same number of the bars in each layer. Cut length, rounding, increment, cut lengths are rounded to the value specified. Longitudinal bar, curtailment, merge identical longitudinal bars if appropriate, merging only. Possible sum of the same patterns. Top bar patterns 1 and 2 don't have any bars that can merge. And other patterns bars are the same size, normal position. Number and position can be merged provided that the total length of the merge does not exceed the maximum allowable bar length. Maximum bar length can be viewed from home materials reinforcement by clicking available bar size and then clicking the view button. They extend the longitudinal support with the bars symmetrically. Extend the support bars symmetrical to both spans of the base on the larger effective span length with only the spans vary less for the percentage size specified. Extend top longitudinal support bars with anchored length. Add anchored lengths for the calculated extension length. Eurocode minimum anchored length is value of the time of the diameter. Minimum anchored length multiple of the bar diameter is controlled within this setting. Minimum anchored length of the plane bar is valued times the diameter. Minimum anchored length of the multiplied by the multiple bar diameter is controlled with this setting is only with the rib type plane. End support curtailment and extend top spans of the end support. Extend with the top span first and last span with the end supports. Use the U-bars end support appropriate under the certain conditions of the option. Replace the top of the bottom bars end support with the region use bar of the bars are joined with the merge to create with the U-bars depending on the top of the bottom parts of the toes of the beam. The anchored length of the result of the U-bars taken with the length required from the pair of the bars made with the U-bar. Extend the bob all bars supporting members widths of the U setting provide with the control of the extension application end bobs within the supporting member to allow the anchored length to reduce the situation where the would otherwise extend too far with the supporting member to an ordinary situation where the supporting members are perpendicular narrow. beams of the bars bobbed into the normal way. In situations, supporting members are wired at the entered value. They reduce anchorage, resolve the anchorage into plane walls. The setting is applied with each end support with the calculated required anchored length. Determine the support width. If the anchorage is greater than support width, covered bob bars. Else if the support width is less than the entered value in setting, extend in bar bars. Else provide straight anchors. Linkage set the same bar size of the support region and span set of the same bar size support span region. Set symmetrically the link of the support region. Select to use the same link arrangement, bar size and spacing in both support concrete beam top longitudinal bar pattern. On this page, use the configuration patterns. Use the bars. Sharing pattern setup longitudinal bar pattern. The drop list. Use the select of the pattern to be viewed. Modify with the design option dialog. Default pattern longitudinal default pattern. Drop list. Use the select of the pattern that gets applied with the new beams when they are first created. The default pattern can not be used to change the pattern associated with existing beams. This only can be achieved by editing the beam properties. Continuous span and cantilever backspan. Tab is due to define how the longitudinal bar pattern gets applied with the continuous spans. Cantilever backspan interactive diagram is displayed with the updates and changes made. Bar checks. Boxes selected bars are dim and mandatory for the selected pattern. Other bars can optionally include a pattern for your preference. Regional fields in which they are applied are defined in percentage and span length. Span span. Tab is defined with how the selected longitudinal bar pattern can be applied. Gets applied to single span interactive diagram displayed with the update for the as changes are made. Cantilever. The tab is used to define selected longitudinal bar pattern. Gets applied to cantilever interactive diagram is displayed with the updates and changes are made. Concrete beam bottom longitudinal bar pattern. On this page, view the configuration patterns. View the bottom bars. Standard pattern setup longitudinal bar pattern. This drop list. View the select the pattern review. Modify the design option dialog box. Default pattern longitudinal default pattern drop list is select the pattern that can be applied with the new beams which they are first created. Default pattern can be used to change the pattern associated with existing beams that can only be achieved with editing beam parts. Continuous span cantilever backspan. Tab is defined how select the longitudinal bar pattern gets applied with the continuous spans, cantilever backspans, interactive diagrams displayed with the updates and changes made. Bar checkboxes. Selected bars are dimmed and mandatory for selected pattern. Other bars are optionally included the pattern according to the preference. Regional fields. The region in which the bars are applied to define percentage of the span length. Bar lapping. Inside support, select the option to lap at the bottom bars in the middle of the support region. Outside support, select the option to lap at the bottom bars of the face support of the region. Single span. Tab is used to define selected longitudinal bar pattern gets applied with the single span interactive diagrams displayed with update changes are made. Cantilever. Tab is to define how selected a longitudinal bar pattern gets applied to the cantilever interactive diagram displayed with the update changes are made. Concrete beam and link settings. Shear design region normals. Consider shear design shear checks performed in each three regions S1, S2, S3 are shown below. Each region maximum vertical shear of load combination determine the maximum value. Determine the shear reinforcement required in the region. Regions shear 1, shear 2, shear 3. Region define fixed portion clear span with a beam by defining extent of shear region 1. Other regions determine automatically link type. Select either open and closed link with a drop list. Shear design region cantilever design shear checks are performed in two regions. Shear region 1, shear region 2 shown below. Link bars a tab define the how selected longitudinal bar pattern gets applied with a single span interactive diagram displayed. Update changes are made. Minimum bar size, shift the minimum allowable bar size that can be used the design process. The maximum bar size, shift the maximum allowable bar size that can be the design process. Minimum spacing, minimum allowable link spacing that can be used the design process. Maximum spacing, maximum allowable link space that can be used the design process. Spacing increment, design link spacing, multiple values. Minimum, maximum link leg spacing across the beam. Value with determined single links. The double links are more required depending on the width of the beam. Using the single outside link option, even the single outside link and additional links are required as per link of the D is dotted below. Except the single line interlink, the option allows you the single line interlinks as per link C is shown dotted below. Option link design regions where possible. In this case, the central shear region 2 with the shear reinforcement provided either the minimum code requirement, either the preference of shear 1, shear 3. Design shear reinforcement required the position length of the shear 2 region shear 2 with the determined consideration shear resistance concrete cross section enable the lengths of the shear 1 and shear 3 to be determined concrete beam and general parameters Euro code reinforcement anchored link parameters used for the calculation ultimate bond stress, for which the anchored lengths are determined the maximum bond quantity coefficients or allow range from 0.5 to 1.0, default is 0.7. Aggregated the maximal and nominal aggregate side of the calculation determine the minimum clearance horizontal distance between individual parallel bars. Allowance for deviation value of the calculation determined limiting the normal concrete cover as common concrete nominal limit. Concrete nominal limit is equal to concrete minimum slash the concrete deviation. ACI fixed city fixed coefficient B1 coefficient supplied with the maximum positive moment in beam span excluding support position set under user defined minimum design moment of the beam support region. Allow range from 0.0 to 1.0. Default 0.25. Deflection, long-term deflection period allow ranges from 3 to 60 months, the default 60. Time of the brittle finishes that introduce long range 1 to 6 months, the default 1. All codes FE chase down, sign beam, the FE chase down analyst report provide FE chase down analysis perform, which require the model to contain two-way spanning slabs. The option used to specify the beams are designed for the forces obtained from an analysis in addition to the force obtained with a 3D analysis, grill chase down analysis, effective flanges calculation tolerance of rectilinearity. Calculation effective of the width of the carried out when the concrete beams, if they were with the tolerance of rectilinearity, set there with the default tolerance of 15 degrees at the greater angles you prompted to enter the effective of the width manually. Design option concrete column. The page several subpages setting up the option you with the column design concrete column reinforcement layout. The page you the set limits of the range spacing of the bars. You with the design general country. The available bar size of the properties are taken from the material of the reinforcement database according to the country selected. Vertical bars, minimum bar size, so for the minimum allowable bar size that you with the design process, maximum bar size, maximum allowable bar size that can you with the design process, minimum bar spacing, minimum allowable bar spacing that can you with the design process, maximum allowable bar spacing you with the design process, minimum reinforcement ratio, minimum allowable reinforcement ratio of the concrete section area, maximum reinforcement area, maximum allowable reinforcement ratio of the concrete section, steel over strength factor ACI only. The factor of the seismic design to account with the reinforcement steel yielding over strength link bars, maximum bar size, maximum allowable link size due to the design process, minimum bar size and maximum bar size that can be used with the design process, minimum bar size allowable link spacing between the design process, maximum bar spacing, maximum allowable linking spacing that can be used with the design process, spacing increment the design length spacing multiple values, confinement reinforcement. The options used to limit the range of the confinement link options apply with the rectangular section depending on the aspect ratio. Section aspect ratio change value entered to determine the rectangular section considered to have the low aspect ratio, considered to have the high aspect ratio. The use of the double links, the low aspect ratio, double links applicable in reference to a single link section with a low aspect ratio, double links high aspect ratio with double links applicable to reference single link section with a high aspect links. Use with triple link, low aspect ratio, triple links applicable to reference double and single links section with low aspect ratio. Using cross links for low aspect ratio, cross links applicable preference the triple to double and single link section with low aspect ratio. Concrete column detailing option setting on the page related to the detail produced if with no effect of the design longitudinal bars cut length the rounding increment cut length the rounded to the value specified. Overall steel bar cut length is stored in the material data home tab of the existing can be verified by the material reinforcement available bar side of click the view button. The kicker dimension, the height of the column kicker cast above the slab level, the joint identical bars when popped. The option select the bars might mirrored only on the bar side layout when the currently adjacent stack identical proof of the max bar length is not exceeded. Links, number of the span region links require that you use in separate region of the column to design with the utilized space of the region of the economized link requirements, however, that only exists over the short length of the preferred the standard length of the spacing of the detail setting allows the specifying the minimum number of the span region, the links for the necessary for the span region to be indicated with the detail, provide links to the full foundation depth, select with the draw links to the full depth of the foundation penetration depth links. If provided links to the full depth and depth option cleared for this becomes accessible, allowable the penetration depth link to the foundation specified, provide links to the floor depth of the internal columns. For columns restraining the flat slab, links are always provided through for the floor during depth irrespectively setting following columns restraining the beam and slab. Links are always provided through for the beam of the depth of the edge of the column, although only provided the internal column when the option is selected when the clear Links are provided with the soffit if the show of the shell is beam depth. Concrete column general parameters. General bar size no smaller than the stack above. The ship of the bar side, but do not reduce the lower stacks. Match bar position stack above. Select the starting arrangement with the longitudinal bars match the arrangement of the bars and stack above the section of the geometry match. Increase main bar size preferentials. Select the horizontal corner bars instead of preference of the immediate bars. All bars start off with the same size unless the initial bar size drive with the current arrangement or stack above with the check veil of the corner bars. Increase the size of the R bar, all bar size, and otherwise immediate bars will be increased size. This means the final design is produced either all bars of the same size, corner bars one side of the large immediate bars, or then intermediate bars. Alternatively, requires all bar sizes to be the same. Clear options result in the bar size being increased together. Her reinforcement anchored to length parameters Euro code only. The parameters used in calculation ultimate bond stress for which the anchor lengths of the determined maximum bond coefficient range from 0.5 to 1. Aggregated minimum nominal aggregated size value of the calculation determine the minimum clear horizontal distance between individual parallel bars. Allowance of the deviation value of the calculation determine the limiting nominal concrete over concrete nominal limiting is equal to concrete minimum with the concrete deviation. FE chase down design column the FEG chase down analysis result will provide FE chase down that has been performed, which requires the model to contain with two-way spanning slabs. This option can be used to specify the column to design with the force obtained with the FE chase down analysis. In addition to the force from the other analysis that have been performed, design option concrete wall of the page serves several sub-pages sub option with the wall design concrete wall reinforcement layment. Pages set limited range and spacing of the bars used in design. General of the country, the average bar size of the property taken from the material of the reinforcement database according to country selected. Vertical bars, you have maximum minimum bar size that can be used in the design process, minimum bar space, and maximum bar spacing that can be used in the design process. Space increment the design spacing over the multiple value over this value, minimum reinforcement ratio, minimum allowable reinforcement ratio cross section area, maximum reinforcement ratio, maximum allowable area with the reinforcement ratio concrete section. Vertical bars in end zone, minimum allowable bar zone can be used in the design process, maximum bar size, minimum and maximum reinforcement ratio, horizontal bar, minimum bar size that can be used in the design process, minimum reinforcement ratio for the end zone area, link horizontal bars, minimum and maximum bar spacing that can be used in the design process, spacing increments, design spacing multiples of the value, link and confinement bars, minimum and maximum bar size that can be used in the design process, coefficient bars in the end zone, minimum and maximum bar size that can be used in the design process, substitute loose bars and mesh inadequate, additional loose bars end zone when the mesh is inadequate, continue concrete wall detailing options. Setting of the page relate with the detail of the producer that have no effective design, longitudinal bars, cut length, rounding, increment cut lengths, rounding with the value specified, overall steel with a cut length, steel bar cut length stored with the material data home tab. For existing bars, verify clicking materials reinforcement, then click available bar size, click view button, kicker dimension, height with the column kicker cast above the slab, level the joint, identical bars for the option select with the bars merge only with the bar size layout with the current and adjusted stack, or identical with the preview of the matrix bar length with the time extended length for the number of spans region lengths for you to separate with the regions, however the wall design be utilize with the span region, the economize link requirements, however they only exit with a short length with a preferable standardized length, spacing with a detail setting all allows you specify the minimum number of spans range and lengths for the necessary for the span region, indicate the detail, provide links through the full down foundation depth, select draw links for the full depth of the foundation preparation, penetration depth of the length, provide links through the full foundation depth, options cleared for the field becomes accessible, allowing the penetration depth of the links of the foundation to be specified, provide links through the floor depth of the internal walls, for walls restrained by flat slabs, links are always provided with the floor depth respectively with the setting, for walls restrained with the beams or slab lengths are always provided through a beam depth of the edge of the wall, only provided internal walls when the option is selected with cleared link, provide up and soffit for the shelves beam depth, concrete wall and general parameters. Reinforcement parameters, length of the parameters, use the calculation ultimate bond stress for which the anchor lengths of the determined maximum bond coefficient or allow range 0.5 to 1, aggregated maximum nominal aggregated size value, the calculation determine minimum clear horizontal distance between individual parallel bars. Allowance of the deviation value for the calculation determining limitation of nominal concrete is concrete nominal limitation. It's concrete minimum plus concrete deviation chase down design columns to FE chase down analysis result. Provide FE chase down has perform a core of the model to contain with the two-way spanning plans, the option special for the wall of the design with the forces obtained with the FE chase analysis, additional forces obtained with the other analysis have been performed. Design option concrete slab of the page have the two sub-pages setting up the option either the slab or flat slab design, concrete slab reinforcement layout. Page has two setup lengths, limits range, spacing of the bar slabs on the beams and flat spaces. General the country available bar size property to take with the materials reinforcement data according to country selected. Principal secondary bars, minimum loose bar size, and maximum loose bar size can be used in the design process. Minimum clearing space, clear bar spacing that can be used in the design process. Minimum spacing slab auto design. This minimum allowable clear bar spacing used in panel out auto design process is only applies to panels that all allows panel design to meet more readily selected bars of wire spacing, while allowing patch design readily pass with reducing minimum space checking failures to patch. Maximum principal bar spacing distance, maximum allowable bar spacing as the distance, maximum principal bar spacing times the slab depth, additional above the maximum distance instead of the maximum allowable bar spacing with a function of the slab depth. Maximum secondary bar spacing distance, instead of the maximum allowable bar spacing that can be used in the design process, maximum bar spacing times the slab depth, maximum secondary bar spacing times the slab depth, additional maximum distance sets the maximum allowable bar spacing function slab depth. Bar spacing increment of bar spacing multiplies the value of the maximum bar length, set the maximum bar length increment of bar length multiples over the value. Slab edge clearance sets the clearance for the reinforcement slab edge reinforcement auto selection auto bars. Select the have the bars outer layer selected automatically. Make a bob at the top steel with the canton lever. Select apply the bob to the end of the top steel canton levers. Use mesh when possible. Select the use mesh where possible. Concrete slab patches. This page separate tabs. The setting of the default property each path tab. Type reinforcement. Use mesh where possible. Select the use mesh where possible. Patch size width LX and LY. Default patch size to be used. Strip portion edge strip width of portion of patch width. The column patch of the ratio control of the patch width split between the edge and center strips. Center strip width of the beam patch is set with the width of the center strips. Concrete slab general parameters, reinforcement anchored length parameters give the calculation ultimate bond stress for which the anchored lengths are determined. Maximum bond quality efficiency range from 0.5 to 10. 1. Cover the spacing, checking parameters, maximum nominal aggregated size value calculation, determine the minimum clear and horizontal distance between individual parallel bars. Allowance deviation in Eurocode. This value is calculation, determine the limiting nominal concrete cover. Minimum nominal concrete cover is equal to concrete minimum concrete deviation. Detailing. Allowance of additional detailing bars. Total mass of the bars. Slab mass shown in material listings from report. Slab detailing properties will be increased percent specified here. Design option concrete punching shear. This page sets the parameter for punching shears and stud rail design. Generally, the country available the bar side of the property. Take the material of the reinforcement data of the country. Select for the reinforcement bars, maximum minimum bar size that can be welded in the rail design process. Diagonal spacing between the bars, like maximum level. The diagonal space for the radial layout. Spacing along rail. Minimum spacing, minimum allowable bar spacing along each rail. Maximum allowable bar spacing around each rail. Spacing increment based bar spacing adapted the multiple value of the view of this value. Spacing on the first reinforcement line, minimum and maximum spacing the column face, first reinforcement line space, increment the space of the column face with multiple values of this value. Auto design method. The auto design can either be set with a minimized bar size with minimized number of rails, certain number of studs per face, the minimum number of studs per face, so that can be used when auto design minima. Digital diagonal spacing between rails for circular arrangement, maximum spacing, maximal diagonal space between the outermost studs of the last critical parameter, spacing between rails in the Y direction, minimum and allowable rate, maximum and allowable rail spacing in Y, spacing increments rail spacing in Y, adopted the multiple of this value, spacing between the Z direction, minimum, maximum allowable rail spacing in Z, spacing increment, Z adopted with multiple values of this. Design options, concrete isolated foundation. The page is sub-pages setting up the options. Use the bad base and PAL cap. Design, concrete isolated foundation, reinforcement, layout. Page has two tabs. Setting limits for the range, spacing on the bars, pad bases, and PAL caps. General country available. The bar size properties taken on the material reinforcement database according to country selected. Principal secondary bars, minimal loose bars, and maximum loose bar size. It can be used in the design process. Minimum clearing space. Spacing can be used in the design process. Maximum bar spacing, maximal allowable principal bar spacing distance, maximal allowable secondary bar spacing distance, bar spacing, increment bar spacing, multiple values, reinforcement, use mesh where possible, select mesh where possible, concrete isolated foundation. Foundation side of this page has two tabs of the setting of the size parameters, view the design process of the pad bases, and pile caps. You have minimum and maximum depth allowable. Auto design depth increment, sets the depth increment, minimum side length, minimum allowable side length, maximum side length under columns, maximum side length under columns as a distance, maximum side length ratio under columns, set the maximum side length ratio under columns, round increment of footing, dimension pile spacing, overall footing size of the rounded end of the value, default 3 pile cap, shape of the default shape of the 3 piles, either to be either triangular or rectangular, concrete, isolated, foundation, general parameters, reinforcement, anchor length, parameters, Eurocode, only parameters, view the calculation ultimate bond stress for which the anchor limits of the determinant maximum bond coefficient allowance range allowable range 0.5 to 1, covering space check parameters, maximum nominal aggregated side, view the calculation determining the minimum horizontal distance between individual parallel bars, allowing deviation of the Eurocode values calculation and limiting nominal concrete cover is equal to concrete minimum concrete deviation, pad base shear reactions at pin base, ACI, ASC, and BS head codes only. Ignorable percent and passive pressure default 1%. Typically negligible load level if you don't want to ignore small shear forces pinned with the base of the set level value 0. Pad base foundation bearing capacity Eurocode only, presumed bearing capacity in EN 1997 1CL6524. Option to select for the bearing pressure for the check for the surveyability combination, presumed bearing resistance, so for the bad pace properties of the STR and GEO capacities. Pile cap design parameters, tolerance of the pile composition, allowable deviation pile position, original pile and pile position will use the design moment calculations. Concrete isolated foundation pile with maximum minimum number of piles caps under the column parameters apply with the pile cap under the column has been set with the auto design with the pile minimum spacing option. Sets where the minimum spacing checking uses set value multiples of the pile width and circumference minimum spacing of the pile set with the minimum spacing values multiple over the pile width and circumference. Minimum pile edge distance, minimum distance pile face to edge foundation pile. Auto design method. The pile cap has been auto designed. You can choose the smallest for the number of the high capacity piles, more piles, lowest capacity. Design option concrete mat foundation options displayed identical to those applied to the slab. Design option for composite beams, effective flange with calculation. Tolerance on rectilinearity. The calculation effectively only carried out with composite beams if they lie with a tolerance rectilinearity. There, the difference tolerance of 15 degrees with greater angles prompted to enter the effects with manually. Design option, design force, ignore forces below. All 3D analysis may expose small forces normally ignored. Design members of the option, ignore forces, design forces page. The design option dialog simply provided you with a way of setting negligible nominal force levels with which we are comfortable. When small forces of 3D analysis are below the specified threshold, they are ignored so they can be proceed automatically. If forces are above the set limit, they will be warned during the design process, but the force will be still ignored. Concrete beams, torsional force, percentage of the concrete resistance. Eurocode design only defines user specified ignorable torque limit if the maximal torsion moment acting on the beam is less than the limited design for the torsion not performed. The setting is only applicable to design in Eurocodes. For all other head codes, it's not used and can be ignored. Design options, design groups. Choose the member type of the group to design to be applied with the group and only one member of the group to design with the design and a copy with the remaining members of the group to be checked with any of the failing members of the redesign with the reprocess with the repeat with all the member passes the design is not possible. Design option, auto design. Option scroll with a half an individual steel concrete member, auto design settings, isolated foundation, auto design settings, end of the design process. First two options, little explanation. Always auto design sets automatically cleared at end of the design process. Put any of the member in the choke check mode. Never auto designs either selected or cleared. Always retained at end of the design process. Third option, when checking status is at worst, makes the change with the auto design conditional upon the design status as follows. Pass auto design setting automatically cleared at the end of the design process. The member's design status pass. Warning: the auto design sets an and automatically clear at the end of the design process. Members of the design status pass warning, fail auto design setting, and only automatically clear to the end of the design process. Members of the design status pass warning or fail, invalid auto design setting, automatically cleared at the end of the design process. If the member of the design status pass warning, fail, or invalid, beyond scope auto design setting, and automatically cleared at the end of the design process. If the member of the design status pass warning, fail, invalid, or beyond scope. Most practical use of when checking status is worst option when checking status is at worst option would be set to pass. Start with all members outside auto design mode at the end of the first design run. Passing members would be set to check mode and always allowing you to focus on remaining members still in the auto design mode. Design options: design warnings, concrete seismic warnings, warnings guidance during the design of the structure. U.S. seismic provisions are in effect by default. They can be deactivated, found useful. Following sections available. Specified grade, concrete grade is too low. Compliance to ACI 318.08, ACI 318.11, section 21.1421. Shall not be less than 3,000 psi. Apply with normal weight reinforced concrete column beams and special moment frames. Apply with normal weight reinforcement concrete walls. Assign specified reinforced concrete structural walls. Prompts the user to increase the concrete grade in the member. Specify the longitudinal reinforcement grade too high, complying with the ACI 318.11 section 21.152 with the reinforcement resting in an earthquake-induced flexure. Axial forces both shall comply with the ASTM A706 grade 60. Applies normal weight reinforced column beams part with a special part. Moment that frames applies the normal weight reinforced concrete walls. Assign special reinforcement concrete structural walls. Prompt the user to lower longitudinal reinforcement grades column at the end of the beam, but not to the same seismic frame. You validate with the frame of the beam as part of the correct setup as to the seismic frame. Applies normal weight reinforced concrete beams as part of the seismic force resisting system, and applies both of the SRFS type direction. Check both ends of each of the beam span. Prompts the user set up the consistent SRFRS type direction between all the members of the frame. Beam at the end of the column is not in the same seismic frame. That you validate with the frame of the column as part of the correctly set up as for the seismic frame. Apply with the normal weight reinforced concrete column seismic force resisting system. Check with the top of each column stack. Prompt use the setup of the SFRS type direction between all the members of the frame. Beam supporting regional size is too small. Complying with the ACS 318.08 and 318.11 in section 21.342. Hoops shall be provided over lengths no less than 2H measure for the face of support members toward the med span. Apply with the normal weight with weight reinforced in the concrete bars with intermediate and special moment frames. Comes into effect with the length of the end of the shearing design region smaller than the requirement. Prompt you with the view of the shear region, design options. High seismic conventional demand at non-SFRS beams. High seismic to conventional demand ratio or non-SFRS columns at high seismic to conventional demand non-SFRS walls. Used as recognized by the member's significant contribution building lateral force of resistance has not been assigned with the SFRS required with the quality ductility property. Specifically apply that each of the member type highest non-seismic design ratio bending shear design is obtained. Highest seismic design ratio bending and shear design is retained. Common effect for the ratio between seismic and non-seismic values is higher given the threshold of default 1.0. Maximum seismic non-seismic ratio threshold triggers warning set through seismic conventional minimum demand ratio. On the same page. Prompt you to include the number FSRS, review structure layout, reduce contribution member to lateral force resistance. Non-SFRS design requirements applicable to the SDC, DF, compliance ACI 318.08 and 318.11, section 21.13.1, requirements section 21.13 apply with the members not designated as part of the seismic force resisting system structures assigned as SDC, DE, and F. Applies normal weight reinforced concrete beams, column walls not included with the SFRS, comes into effect the seismic design category SDC, D, or above. The prompt you to apply with the code with the prescribed requirements of the top current design, seal, static warnings, additional notational loads applied when alpha PR /PY is greater than 0.5 C23, compliance 7.33 IAIS C360.05 C23 AISC 360.10 required of the stiffness certain members of the reduce the ratio of the required axial compressive force or the axial yield length strength PY is equal to FY AG is greater than 0.5, and then the stiffness must be reduced further. Alternatively, whichever the approach of the Tekla structural design, an additional notation load of 1,000th of YI can be applied instead of the program and identified with the ratio PR to PY exceeding 0.5. Warning is given an alert to the designer. If the additional notation load has been dealt with the designer, then this warning is no longer relevant. The option allows you to switch off the warning. Concrete seismic conventional minimum demand ratio. The ratio of the thresholds above the high seismic and conventional demand warnings come into effect. The design option steel joists. Loading pattern. Each joist is set for classified uniform, near uniform, equivalent uniform, non-uniform, taking account of the defined tolerances. Uniform load tolerance calculated percentage load tolerance is less than value load classified as uniform. Equivalent load tolerance calculated percentage load tolerance greater than value loads classified as non-uniform. A 0 point equivalent load tolerance is specified only in pure uniform loading accepted. Maximum century of zero shear of the equivalent uniform load method position 0.0 shear relative center span point with the joist determined located outside maximum eccentricity 0 shear value loaded to classified as non-uniform. Deflection increase allows shear the deflection due to the live load calculated with the following ineffective inherent value inherent effectively equal to inherent gross plus 1 times R. R is the deflection allows increase allows shear effects default to 15% applied with the CKS only. Design option wind drift. The wind drift check was performed on all columns apart with a wind drift check with a select with the property for the combination of containing wind load cases. Check wind cases only when the setting of the default wind drift check only considers the effects of the wind load case and each wind combination. With the setting of the check, consideration affects the load cases of the wind combination would include the drift, included gravity load. Static analysis and design. Remember the design mode. Before starting an analysis design process, every design member in your model will be set to one of two models. Check design mode. You're assigning your desired section size, steel member, section size, reinforcement, concrete member of the program that determines for the section of the reinforcement sufficient. Auto design mode. Select design desired section type of the program and automatically determine the suitable size, choosing section size type steel members, or assigns you the desired section size programs automatically determines suitable size reinforcement configuration concrete beams members. You can quickly review update with the mode applied with every member in the model with the auto check the design toggle with the review toolbar. Once the auto design check and design modes have been set appropriately, you can then begin with the member design process. How you choose analyst design process to run in effect with the materials either the steel, concrete, or bold. Also, with the combination of type of the conserve the gravity of all and steel structural particular make require initial gravity design. How to run design steel, design concrete, design all. Your choice will depend on the materials on the model. In simple terms, if the model consists of steel members only, you can run the design analyst design steel group in the design toolbar, design steel gravity, design steel static. If your model consists of concrete members only, you can run the design from the analyst design concrete group, design toolbar, design concrete gravity, design concrete static. If your model consists mix of both concrete and steel members, you can run the design analyst design group design toolbar and design all gravity, design all static. For structures more easily steel with a few concrete members instead of the running design or the running design and focus the steel design before switching design concrete remaining members of the during steel design phase for the not running the grillage FE chase down analysis when they are not required. Process for the get initiated reflect your choices. Follow the design steel to perform 3D analysis. Does not perform grillage chase down FED chase down analysis. Design checks all steel elements share wall that does not design check concrete beams and columns. Design concrete. Perform 3D analysis, grillage, chase down analysis based on all the required. Perform FED, chase down analysis. Design checks all concrete beams, columns, and shear walls. Not design check steel elements. Perform on 3D analysis, grillage, chase down analysis. May also required to perform FED, chase down analysis. Design checks all concrete beams, columns, and shear walls. Design checks all steel elements. How do I run a design gravity or design static? Design gravity, although final decision should be considered all the combinations. Design gravity combination can be a useful way to rapidly produce out of the members and structure that are not subject to lateral loads. Design members of the gravity combination technically more likely to be employed with steel rather than concrete structures. Technique involved first order analysis, limited set design combinations. Design steel gravity, rapid gravity sizing of the majority steel members to design concrete, gravity design concrete members for the gravity combinations only. Design all gravity design steel and concrete members for the gravity combinations only. Because the lateral system may not have been established in the state of the column nodes of the not rigid floor diaphragm may by default fixed horizontal. The defaults can be changed with the required home setting design options, general design static. Once the initial member size has been adequately sized, you may make a sway sensitivity assessment, ACI-AISC, that can affect the choice of analysis type of ACI-AISC used in the final static design. Final static design is evoked by selecting design static process applicable to the type of the material involved. Design steel static full design of all the steel members. Design concrete static full design of all the concrete members. Design all static full design of all steel and concrete members. For each above 3D analysis, perform first and second order, specify the design option analysis for all the combinations, establish set of the design force on the model containing the concrete member, the grill chase down, power potential, FE chase down, performance essential, establish additional set of the design force, all members check with the design, appropriate design requirement, gravity members check with the gravity combination, lateral members are checked for all the combination, only combinations are checked. Part design steel gravity, perform an analysis with active all gravity load combination of the design check with steel members, 3D analysis running excluding pattern loading, establishing set the design for steel members above in the analysis lateral transitional fixed support that can optionally be applied by the common nodes and other remove unwarranted lateral displacement, preventing analysis of completing and producing unrealistic control V with the settings design option general home ribbon. Each gravity only steel member is either checked or designed according to the auto design setting of the gravity combinations. Only the remaining steel members except for the auto design with the gravity combination to give them reasonable start size prior consideration lateral load combinations. The remaining steel members to be checked design are not checked on completion of the gravity sizing process. All steel members are to be set check design mode, and at the point of this possible lateral members are undersized has been designed with the gravity combination only, so that recommended to reset them while design mode continuing the design process. No design force established in concrete elements multi-material building. How do I run a steel gravity? How do I run design steel gravity? Part of running design, you should have the sign appropriate auto design design steel members, auto design on new section sizes of the design, auto design off existing section sizes will be checked. You should be aware of the design option within their place, particular design option analysis type to be run, design option design forces set at the level of the forces be ignored, design option auto design control of the auto design will be reset after design to run the design, check with the design steel gravity. At the end of the analysis, the design profit, the active view switch for review with the view of the tab switch design to review, ready for the reviewing the design graphically, design static steel, perform analysis all active steel load combination, gravity lateral, ELF size, making the design check every steel member, overview first order analysis, unfactored load case carried itself with serviceability limited state of the requirements of the such as the flexion, equivalent horizontal forces determine every active combination which they have included have established equivalent horizontal forces, contribution frame deflections, or determine the U of the first order analysis values are established. 3D and analysis performed for a second order of the design option analysis. All combinations established set design forces. All steel members, auto designs are designed appropriate design requirement. Gravity members are designed gravity location combination. Lateral members are designed for all combinations. Only active combinations are checked, and the section size are changed. The analysis of the design cycle is repeated. All steel members set with the check mode are given appropriate design requirement. Gravity members are checked with the gravity combination. Lateral members are checked with all combination. Only active combinations are checked with the end process. Although design typically clear, putting every member in the check mode, you can change this required with the design option auto setting. How do I run design steel static? Prior to running steel, prior to running the design, you have associated assign appropriate auto design setting. Steel members auto design on new section size will be designed. Auto design off existing size section will be checked. You should be aware of the design option gear that are placed in particular design option analysis sets the analysis type to be run. Option design forces set the level of the forces be ignored. Design option auto design controls auto design settings will reset after design. To run the design, click design steel static. At the end of the analysis design process, active the use switch of review view and tab switch designer to review, ready to reviewing the design graphically. Design concrete gravity, perform an analysis for active gravity load combination. The design checks every concrete member but not concrete slabs. Overview 3D analysis runs established design force concrete members above the analysis lateral transition. Fixed loads optional. Apply with the column nodes ordered to remove the unilateral displacement. Prevent the analysis from completing and producing unrealistic forces. Control V with the setting design option. General home ribbon. General grillage chase down analysis performed. Establish second set of the design forces. If the model contains flat slabs or slabs on beams, FE chase down analysis also performed. Result being optional E. You have to establish third set of the design forces. Concrete beams, column walls. Every concrete member is either checked or designed according to the auto design setting for the gravity combinations. Only no design forces are established in CLML's multi-material building. How to run design concrete gravity. By running the design, you should have assigned appropriate auto design setting. Concrete members auto design on new and reinforcement. Design auto design off existing reinforcement will be checked. You should also review the design options that are replaced. Do this by clicking design options to run the design. Check with the design concrete gravity. At the end of the analyst drop design process, activate the view switch of review view. Tab switch design to review the reviewing the design graphically. Design concrete static. Perform an analysis active static load combination gravity lateral ALF size, making the design checks every concrete member. Overview of first order analysis unfactored loaded cases carried and established serviceability limited state requirements. Equivalent horizontal forces determined at every action combination which they are included. Having established equivalent horizontal forces contribution frame deflection determined to be the first order analysis value for all established. 3D analysis perform first and second order specify the design option analysis all active combinations establish set the design forces grillage chase down and analysis performance set. The second set of the design force model contain flat slabs on beams. FE chase down analysis also perform result being optional. You the established set of the design force concrete bombs column walls. All concrete members are auto design or design appropriate design requirements only combinations are checked. Concrete members set to check the mode. The appropriate design requirements only active combinations are checked. End of the process auto design settings are typically retained. However, you can change the required design option auto design and then how do I design concrete static, and we're going to cut the tape there.